In this video, we will discuss one-dimensional motion, that is, motion in a straight line. Before we discuss motion, let us revise scalar and vector quantities. Scalars are quantities that can be completely described by magnitude or simple quantities that just has a value. Vectors are quantities that can be completely described by magnitude and direction. That means you need a value and a direction to describe that particular quantity. So every time you have a quantity and you have to decide whether it is scalar or vector, ask yourself a question: the magnitude in which direction? If there is a meaning to the question which direction, then it is a vector quantity, otherwise it is a scalar quantity. Based on that concept, let us try some examples. Let us divide these given quantities into scalar and vector quantities. Let us start with time. So let us say it is 5 o'clock. So 5 o'clock in which direction? Now that's just meaningless. So time is a scalar quantity. Acceleration. For example, let us say the car accelerated from 0 to 3 meters per second in 20 seconds. Now here the question, which direction implies that the car accelerated from rest to a certain speed. The same can be applied when it has decelerated or the speed has reduced. Hence, the question here, which direction has meaning. So, acceleration is a vector quantity. Mass of an object. So, mass of an object is 10 kg. In which direction? That's again meaningless. So, mass is a scalar quantity. Temperature. The temperature these days are crossing 40 degrees centigrade. In which direction? Again meaningless. So, temperature is also a scalar quantity. Force. So, we apply a certain magnitude of force, but it matters you apply in which direction. It has meaning, hence force is a vector quantity. Energy. I have lots of energy today. In which direction? That's meaningless, hence it is a scalar quantity. Momentum. Momentum, as we know, is the product of mass and velocity. So in which direction? That will be the direction of the velocity, hence momentum is a vector quantity. Weight of the body. Now weight of the body is nothing but mass into gravitational acceleration, hence weight is nothing but a type of force which makes it a vector quantity. Keep in mind that this is a simple method and would not work for complex quantities like current or force fields. Now let us talk about motion. So motion is defined as change of position with respect to time. A frame of reference is always considered. So if the object changes position with respect to the frame of reference, then it is termed as in motion, otherwise considered stationary or motionless. Let us consider the gray background as our frame of reference for this star object. So currently the star is not moving with respect to our frame of reference, hence we called it as motionless. Now the star is changing position with respect to our frame of reference, hence it can be called as to be in motion. Let us get familiar with terms from one-dimensional motion. Consider a circle BCA. Let the object move along the arc ACB. Here AB is the diameter, hence the value will be 2r, and ACB being the semi-circumference, hence it is going to be pi r. The first term here we defined is distance. Distance is defined as the actual path length traveled by the object, hence here that will be equals to pi r. It is a scalar quantity and it does not account the direction of the distance covered. Displacement is the shortest distance between initial and final position. It will always be a straight line. So here that will be the distance between A and B equals to 2r, or that is the value of diameter. Displacement is a vector quantity, as it is important to mention whether the object moved from A to B or B to A. Note that if the object moves in a straight line without changing or reversing its direction, then distance and displacement are equal in terms of magnitude. Next, we define speed. Speed is defined as rate of change of distance, that is nothing but distance upon time in a simple term. Then velocity. Velocity is the rate of change of displacement. In simple terms, displacement upon time. Velocity is a vector quantity and you will need to specify the direction in order to explain velocity completely. Magnitude of acceleration. As given, it is the change in speed upon time, or we can call it as rate of change of speed. Acceleration as the vector quantity is termed as rate of change of velocity or change in velocity per given time. Note that acceleration is dependent on velocity in terms of magnitude and direction. So if magnitude changes, then there is acceleration, or only direction changes, then also there is acceleration, and if both changes, then again there is acceleration. Let us have a look at the units and dimensions. Distance and displacement are ultimately a measure of length, hence unit is meter, dimension L1. Speed and velocity, meter per second, that will be L1 t minus 1. And acceleration is meter per second square, hence L1 t minus 2. In the next video, we will discuss about types of speed, velocities and acceleration and solve example to understand them completely. Subscribe to the channel to get notified when I upload the next video.